In this lecture segment, we'll look at food and agriculture and their implications for the environment. Recall from our last lecture on climate change that food production in the form of beef production has had a great impact on the increased production of greenhouse gases in the form of methane, and that likewise changes in climate may impact our ability to produce food to feed the growing world population. To begin this lecture, we'll look at a series of photos from different countries around the world that take a look at the types and amount of food consumed in a week. These countries include both developing countries, European countries, and the United States. And then we'll think about what the weekly food bill for these countries is. To begin with, in Germany, and also take a look at the family size in each of these following photos. So for a family of 4, in this survey, Germany had the highest food bill. Take a look at the amount of packaged food, processed foods, and meats in this diet. Next, we see the United States has a substantially lower food bill, but likewise is very dependent on the inclusion of processed foods, packaged foods, pre-cooked meals such as pizza and other things. In Italy, we see a lower food bill, but still not a low one, but great increase in the amount of fresh foods, vegetables, fruits, still a certain amount of packaged foods, but greatly decreased from the first 2 examples. In Mexico, we see a mix of both, a lot of fresh foods, vegetables, fruits, and so on, but quite a bit of packaged foods, mainly in the form of bottled sodas and drinks. In Poland, you'll find less packaged and processed foods, still a small but extended family, and quite a bit of fresh foods and low processed foods. In Egypt, we see a dramatically reduced weekly food bill, a large extended family, and a diet that is dominantly consisting of fresh foods and unprocessed and unpackaged food materials, and relatively few bottled drinks and other materials. In Ecuador, we see a fairly large family, but one that's almost entirely based of raw vegetables, foods, grains, and such, cooked internally in the house. Take a look at as we talked about indoor air pollution, take a look at the walls in the back of the dwelling, covered with soot from the internal fires. In Bhutan, we see, again, heavy reliance on rice, certain amount of vegetables, almost no packaged or processed foods, and again a large extended family. And then finally, Chad shows an example of a family living on subsistence food materials, largely from a refugee camp, and mainly grains with limited amounts of vegetables and other food types. So we see there's a wide variety of food consumption across the globe, and it scales directly with the degree of economic development and finances available for food consumption. All of these foods are dependent on our agricultural systems across the planet, and nowadays much of the food we eat comes from very distant countries. Should be reading chapter 18 on this section on our introduction to food and agriculture. So our food and our food system is, like any system, one that is subject to inputs and outputs, checks and balances, and that many systems will stay in some sort of balance or equilibrium depending on how the inputs and outputs change. This sense of system equilibrium, in the case of animal populations, other organisms, has to do with the availability of food, the presence or effects of predators, availability of habitat, and disease. We don't think in human populations much of these terms anymore, but ultimately that was the sense in our early system. of human development. Our early food system was one that began in our hunter-gatherer mode and has changed with the development of human society, and rapidly took on this interaction of agriculture as a practice, growth, changes in population, and the advent and development of various forms of technology. Each of those three components, agriculture, population, technology, was one that had an impact on the others, and all of them solved some problems, mainly the chief one being increased availability of food, but also created new problems, especially in terms of effects on the natural environment. Agriculture as a practice began some time ago. It's been estimated or observed that with the end of the last ice age, humans, as they shifted from a hunter-gatherer nomadic subsistence form of food systems to agriculture and planted crops, was the beginnings of modern agriculture. So it was in that time where we went from mobile food gathering to in-place food gathering and production. And agriculture, or the synonymous term farming, describes the practice of cultivation or domestication of plants and or animals for food. So how do we get our food from these systems? The main impact of agriculture 10,000 or so years ago was that human populations at the time, although fairly small, were able to derive steady, more reliable food sources. And as food became more readily available, and eventually humans learned to store food in times of more bountiful harvests, were able to increase their nutrition, improve their health, lowered the death rates, and they contributed to economies and other practices and skills. And these other pursuits culminated in the development and recording of knowledge, the advent of larger groups of people, eventually civilizations, and ultimately modern societies. Farming technology was important through that process. Early in the development of farming, it was what you may picture primitive agriculture as being: simply keeping animals, slaughtering them for meat or hides, keeping them for milk or fur production, planting seeds. And the seed planting and cultivation took advantage of crude plows and cultivators to work the soil. These were in turn drawn by animals or slaves. In agricultural areas, in the tropics especially, terrace farming on steep slopes was invented to keep soils in place and farm in less hospitable, simple places. And in arid areas such as Egypt, or early on in Egypt, and other parts of the Middle East, irrigation practices moved water from places such as rivers like the Nile into adjoining flood terraces and allowed irrigation to spread over larger areas. One of the major advances that occurred in farming was that humans learned to select and then crossbreed plants and animals to enhance and extend favorable traits, whether it be larger fruit or larger yields of grain, bigger animals, greater milk production, and so on. But it was this crossbreeding through the selection process that allowed humans to actively manipulate their food supply. The science of plant breeding and the technology that came with it, and the use of tools and other devices in the farm, really started to expand during the Industrial Revolution in the late 1700s. For it was at this time that advances in steam and other forms of locomotion, manufacturing of wheels and other tractors and other devices eventually allowed farmers to more efficiently and more quickly clear, level, and plant expanded number of acres. They were able to change forest into farmland and further increase the food supply. And it was also during this time, with the beginnings of modern biology and plant biology, that the study of plant hybridization became into its own and further increased the breeding and selection process ability to further improve crops. At this time, the human population was starting to increase, and this had both, again, a cause and effect on agriculture. If you recall from our earlier lecture that the exponential growth curve between about the end of the last ice age, about 10 to 11,000 years ago, to the 1500s, there was a fairly steady, slow growth in the human population, estimated about 100 to a million, growing to about 500 million by the 1500s. Following this time, though, over the last 500 years, this population, or human population, has grown at a more exponential rate and reached over 7 billion people at the present time. And this is related to, again, the availability of food through agriculture and its connection with technology. And it was this convergence of the agricultural advances, growth in population providing both the demand for food and also the populations to work food production systems, and technological advances which really enabled that the start of that exponential growth, reaching about 2 billion people in 1930. But it's interesting to note that even by the 30s, all of the food production going on at the time, by today's standards, would have largely been termed organic farming. There was very little or no use of fertilizers other than natural fertilizer sources, and pesticides other than some very basic inorganic constituents were not really, hadn't been developed yet. It was later that these less organic forms of agriculture developed, as we'll talk about in a moment. But it was following this time in the after the 1930s, and especially in the 1940s, with post-World War II upheavals and food shortages that occurred, that the widespread hunger and limited food supplies started to motivate both governments, scientists, and organizations to start to worry about food production worldwide and spawned what we refer to nowadays as the Green Revolution. Beginning in Mexico in the mid-1940s, teams of American researchers were working on breeding advanced varieties of wheat, and they developed seeds that were much more productive in terms of their yield of wheat tons per acre. At the same time, companion work led to rapidly improved staple crops such as corn, rice, and other grains, and they were also developed and shared on a global scale. So this beginning of the Green Revolution from the 1940s was very important. There were a variety of weapons or tools that the Green Revolution brought to bear on increasing and maximizing global food production. These included high-yield seeds, continuously improving modern farm equipment and methods, and then what changed us from more of an organic form of gardening to a less organic type were the scientific advances in chemistry and organic chemistry that led to synthetic pesticides and fertilizers. All of these efforts were extremely successful, such that farm production globally expanded rapidly, and the production skyrocketed, and yields increased many times over, and food shortages became much less frequent, and famine was staved off in many areas. This concludes our first section of the lecture on agriculture and food. You should begin part 2 next. So By the end of the Green Revolution, which is estimated to be sometime in the late 1970s, the world population had continued to grow, and in this case, much more rapidly. Had doubled again, and we had approximately 4 billion people. And despite this growth and these large numbers of people, there were actually food surpluses at times. Although some places like China, which are more closed societies then, had food shortages due to their disproportionate growth in population. But globally, the Green Revolution had shown tremendous success. During that time, and contributing to the success of the Green Revolution, there had been some major changes in overall farming practices, especially in developed countries such as the United States. Prior to the 1940s, the Green Revolution that followed, farming was dominantly based on natural ecosystems and was closely tied to more natural processes, and again, we would view them in many ways much like organic farms. Following the advent of the Green Revolution and to date, farming has been pretty much redesigned to resemble much more of an industrial model. Industrial farms have several common traits. The farm itself functions and is viewed much as a factory would, that you feed it inputs of raw materials, energy, water, and such, and then yield or reap the outputs, whether it be producing from crop materials and plants or from animals and animal products. One of the key attributes has been that this industrial model has seen the growth of increasingly large farms. The small family farms have struggled financially for a variety of reasons, and many have gone out of business, and the land's bought up and put into corporate ownership, and again on a much larger acreage basis. And that efficiencies, again with the advent of cropping systems, increased mechanization, fertilizers, pesticides and such, as followed a bigger is better model. The inputs for these industrial crop farms include water, seeds, increasingly pesticides, herbicides, synthetic fertilizers, energy to move these materials and operate farm machineries and such, and then the machinery itself. The outputs in most of the crop farms to date, at least in terms of raw acreage, include grains such as wheat, corn, rice, soybean, and oats. These in turn are used for animal production, especially in the case of corn, and in the future there's an attempt to push corn more into the biofuels market. Another key facet of the modern industrial farming model has been specialization. The efficiency demands to grow one thing extremely well was very specialized and focused machinery, chemicals and such. It specializes one crop, and this has led to a major practice and a very important concept known as a monoculture. So in a given corn farm or planting, you'll have a single type of corn often that is a single species and a single hybrid, very carefully chosen for its productivity and yield, but only a single genetic variation. Animal farms and animal factory farms as such have taken a similar factory approach, and they've devised the inputs as the animals themselves in the juvenile form, grain as a feedstock, increasingly antibiotic to deal with the health effects and the diseases caused by confinement spaces and very tight packing of animals, and then of course water and energy. And the output has been dairy products, eggs, meats, hides, or other materials. Some of the major traits of the factory farms include due to efficiency demands, a larger number of animals, the larger buildings or lots, closer quarters of animals, packing more animals into smaller spaces. This in turn leads to disease requiring more medication And typically you'll see a specialization in a single type of animal, cows only, or chicken farms, pork, and so on. When you talk about animal farms of the factory variety, these are commonly referred to as concentrated animal feeding operations, or CAFOs. And these have, again, major impact on the nature and type of meat that's produced in this case, and also in terms of their environmental outputs of air quality problems, air pollutants, water pollution, smells, and other environmental degradation. So over time, it was realized that this industrial farming approach led to certain outcomes from the farm that meant that the places of the green revolution weren't necessarily so green by our use of the term in the modern language. There are significant wastes that come off of crop farms. Fertilizers, pesticides, and herbicides are not always, but sometimes sprayed at levels greater than needed, or that the application can't be successfully controlled. This can lead to runoff and discharge of those chemicals that can contaminate soil, water, air around the area, and especially downstream streams and rivers. Another major concern is that the efforts to control pests and weeds can cause a tolerance building for these chemicals, making them less effective. And thus more chemicals, more pesticides are applied at greater quantities, and more excess can be released to the outer environment. Some of the other consequences of industrial farming is that there are downstream impacts. A lot of the problems and the pollution that has occurred related to farming practices aren't isolated to the farms themselves, but affect the larger watershed, and especially downstream receiving waters and even human populations. Water pollution that may start on a farm in Illinois or Missouri or anywhere upstream of, say, the Gulf of Mexico can end up in the coastal waters. Many of the farm chemicals, especially the pesticides, can persist in the environment. DDT, one of the most infamous of pesticides, is one that had a half-life of 35 years, meaning that its natural breakdown would only half of it would break down over a time frame of 35 years, and it literally would take centuries before it would completely degrade down to trace amounts. And during that time, it would carry significant environmental impacts. Pollutants, again, can be transported by runoff and water, and also by windborne transport, and that the nitrogen-based fertilizers leaving farms have contributed to the algal blooms we've talked about, and that this has led to the development of dead zones in coastal waters and nearshore ocean areas. So water quality problems, especially downstream of farms, have been increasingly significant. This diagram shows the development of the developments of resistance to pesticides. If you have an initial pest crop and you spray it with pesticides, a certain number, maybe a small fraction, of the pests will survive because they're genetically equipped to resist the effect of the pesticide. They reproduce in numbers, and the next generation is more resistant, so pesticides are applied again, that further reduces the non-resistant individuals, and eventually you have a total population that no longer responds to the pesticide and takes other forms of pesticides, or typically farmers will increasingly load the crops with pesticides until such time as they determine that those are no longer effective. So the development of pesticide resistance is a serious problem that we face in modern industrial crop farms. Other consequences, as we noted, that if you have large numbers of animals in a confined area, especially cattle, they can release large amounts of methane, which is a very important greenhouse gas. Thus, modern agriculture can lead to a buildup of carbon in the atmosphere and ultimately climate change. And it's a concern that the antibiotics and other drugs used in the production of meat, for example, can be passed on to the consumer. And there have been numerous health concerns raised over, especially in teenage males and females, the presence of elevated hormone levels and other antibiotic type drugs that are consumed along with meat products. Some of the other consequences also include the fact that the monoculture farming will deplete the soil because the lack of rotation of crops will successively take especially trace nutrients out of soils and thereby reduce the overall nutritional value of the crops over time. And it's noted that there may be, on good years, enough food production to cover world needs. However, nearly 1 billion people of those populations that are being fed, especially through aid shipments, are typically underfed and/or malnourished because of the types of food grown and distributed are not necessarily balanced in their nutritional content. With the rise of farming under the Green Revolution, corporate interests have taken interest in the value and the opportunity to make profits. And that as the industrial farming models have reshaped the methods of farming, the corporations of America especially have reshaped the business of farming. And that the corporate approach in translating, say, factory production models and methods in the manufacturing sector to farms has contributed to and dominated this conversion of farms to be treated much more like factories. And again, this is closely tied to corporate ownership, where there's a distant ownership and little or no stake in the local community. And that many of the largest farms and the confined area feeding operations in the U.S. are now owned by corporations. There are some other trends related to this that are kind of the future of industrial farming, and that's that corporate owners now are trying to focus more and more on vertical integration, meaning that they take control of both the farm's inputs and outputs themselves, not just the farm operations, but also the food markets, or treating the food markets as commodities, and manufacturing and marketing the processed food. So everything from the water supply and the energy that's produced, the pesticides, fertilizers, feedstocks, seed companies and such are owned all by a single entity. So the ownership of every aspect of the final food product is owned by a single corporate owner, again with very limited connection with or relationship with local communities. The next phase of the Green Revolution, and what's referred to as Green Revolution 2.0, involves the genetic engineering of seeds and animals, whereas selective breeding and selection of favorable traits over multiple generations led the advent of modern agriculture. The next phase is viewed as direct manipulation and not waiting for gradual trials, but going directly to engineered properties, characteristics, and productivity of both plants and animals. The genetic engineering, then in terms creates what are referred to as genetically modified organisms, or GMOs. And it should be pointed out that the GMO itself has not necessarily been developed as a response to feeding the world's food needs. It has been developed dominantly with the U.S. agribusiness and agrochemical companies who control many of these seed types, and again, through vertical integration, seek to dominate current U.S. food production. So this is more of a corporate purpose than a food production, a global consciousness food production tool. And it's interesting to note that neither the European Union nor China will allow genetically modified seeds or products grown from genetically modified seeds to be imported. The process is described well in the book, but it involves using a certain type of bacterial cells, isolating some genes of interest, copying those, reinserting them back into the plants, and then growing the plant cells with the modified gene to allow the plant to, say, provide a toxin to kill pests or to resist frost damage. There are a variety of different genetically modified characteristics that have been introduced. The response of the consumer public to GMOs has been mixed, to say the least. There is extensive debate. There's a lot of uncertainty, in some cases fear over GMOs and their consequences. You'll hear them referred to as frankenfoods. We simply don't know, given that they're very new, what all the consequences and the end effects of engineered organisms might be. There are ongoing debates, legislation, regulatory fights at the local, state, and national level seeking to determine what and how GMOs will be used and introduced into the food systems. There are extensive lobbying efforts that are well financed by both the industries, the producers of GMOs, and their related food interests, and that one of the major features, major requests by the consumer public is simply to have GMO presence in foods be clearly portrayed on labels so that consumers can make an informed choice. But even this has been resisted by the agricultural industry. So with the Green Revolution 2 and all of the other modern agricultural practices we've mentioned to date, we return for the moment to look at sustainable agriculture as a goal and as a practice, given some of the other sustainable practices we've talked about. And it's interesting that we simply need to look at natural systems, natural ecosystems, in terms of the diversity you find that could influence plant productivity and food production success, and also to examine past practices. Because as it was pointed out, is that up through the 1930s, world food production was very successful, if not completely able to keep up with the rapid increase in human population, but that organic food production served us very well for a long period of time, from the advent of modern agriculture up into and through the 1930s. Organic agriculture and sustainable methods will avoid the practice of monoculture and provide a more diverse farm environment in terms of multiple different species. And they'll avoid the use entirely of synthetic chemicals and fertilizers. They'll implement crop rotation to replenish the nutrient quantities of the soil without having to rely on synthetic fertilizers. Organic agriculture places an emphasis on native nutrient cycling from animal waste back into soil. This in turn feeds ecosystems on the farm that are very similar to natural systems, and they can enhance the plant and animal biodiversity. I strongly encourage you to read the sections on the Massa family farms that are outlined in the book. I've visited their farm operation, and they've done a remarkable job of taking modern ecological knowledge and science into developing a diverse yet very productive plant and animal production system. So if you are concerned about some of the trends in agriculture, there are a variety of different changes and remedial solutions that are available. At the community level, it's possible to engage in industrial planning, couple that to public policy, and seek an implementation of principles of what's referred to as industrial ecology. and this ties together the farming industry and the farms so that waste between different operations can be reused and recycled without being truly waste, and this can reduce the energy requirements, the pollution output, and improve the biodiversity and other aspects of modern farms. Because it's clear that modern farming will include industrial operations at some scale. On a product scale of food production, as a consumer, you can and do tend to vote with your wallet. So the products you purchase or choose not to purchase, especially with feedback to the food vendors, whether it be a grocery store, farmer's market vendor, can engage different types of production and practices that you feel are more appropriate. Local farmers and local farmer markets are an important source of the food system on a scale where they're available, and they're becoming increasingly an option. You can look for them in many communities increasingly, and you can look for the products of those local and farmer operations through organic and at least locally produced food products by asking for them at your grocery store. And then finally, one of the most important things you can do coming out of this course is to inform yourself about what you're eating. And that starts with labeling so that you can determine what you're consuming and hopefully where it's coming from, whether it's a local product or one from Chile or one from China or any particular market, that you know what you're eating and where it comes from. That allows you the choice of which foods you want to purchase. So what can you do about your food? The book suggests some practices that make a lot of sense. Becoming a local gardener of your own, starting to grow your own food, even if it's on a limited basis, is a great place to become more aware of where your food comes from. If available, you can volunteer or work as an intern with an organic farm, and you can talk to your school or university about and request that organic or locally purchased foods be used in the food services systems. This concludes the second part of our lecture on agricultural and food. You can proceed now to the third part, where we talk about fisheries as an aspect of modern food supplies. In this lecture segment, we'll take a look at a very important aspect of modern food supply, that derived from the oceans and seas in the form of fisheries, and in the future turn towards aquaculture, which is covered in more detail in the textbook, and you should be reading chapter 14. To begin with, we look at the definition of the term fishery. This is an aspect of the industry devoted to commercial fishing and places where fish are caught, harvested, processed, and sold. This can occur on large factory ships or in coastal areas. And then the question of why this is covered and why this is an important topic has to do with the fact that in the modern world, large segments, as much as 15% of the world's population, are heavily dependent on fish for their protein needs. And this is especially true in poorer nations, developing countries, where the fish, which is takes minimal effort to gather and is a major and cheaper source of protein than others. In recent years, wealthier nations and developed countries, and especially places like the United States, a health-conscious consumer population has placed a greater emphasis on the omega-3 fatty acids, and certain cold water fish are very high in that nutrient. And in general, it's been advertised and is true that fish protein is a very healthy source of protein to meet our protein needs. What's the outcome of this is that between developing countries and developed wealthier nations, we have increasingly become reliant on fish species, and the global industry has become huge. employing over 200 million people and providing a global revenue estimated of about $130 billion. So there's an enormous financial stake in this for the companies and smaller individuals involved in this industry. However, with the increasing demand for fish from a protein source or health source, the increase in fishing has had increasing impacts on the ocean environments. And the main consequence of overfishing is what's called a collapsed fishery. And this occurs whenever the commercial fishery, in a commercial fishery, the annual catches drop below 10% of their historic high. The example covered in the book is the Atlantic cod, which is heavily fished in the Grand Banks area, the northern Atlantic, especially by the Canadian fisheries. So what causes the collapse of a fishery? It's a major outcome of a number of different factors. Technological advances in the shipping, catch and harvesting, the increased demand for fish, which we've already talked about, and the fact that when you have multiple countries and multiple fishing interests within a given country, you have a tragedy of the commons. And from a global standpoint, the fishing industry and the governments involved don't place an adequate value on the future value of that fishery. There have been many major technological advances in the production of fish, and this is parallel to a large degree the Green Revolution and post-Green Revolution food processing industries. The early advent of steam engines to drive ships at a less wind-dependent fashion, and more recently in modern times, flash freezing and large trawler ships that can drag huge net behind them are some of the major factors that have increased the production of fish from the fishing ships, but at a significant cost. Fishing vessels travel further into the ocean and catch more fish, and then they transport them even greater distances than ever before to meet the growing demand in the market, both from a developed and developing country perspective. Overall, this increase in or improvements in technology contributed significantly to declines in global fish stocks and in particular species at a greater extent. The environmental effects of these fishing technologies are that the large fish with their huge nets dragging them, especially over the bottom, have the consequence of what's called bycatch, where they catch species that are not necessarily their commercial targets. The nets, if they're dragged over the surface, can damage the seabed and create huge sediment plumes that can cover and smother marine life in many cases. The pollution is another factor that comes from the exhaust and discharges from the ships themselves. Materials dropped overboard contribute to plastic and other forms of pollution. And again, this notion of bycatch is an important problem in that non-target species are caught in greater numbers than the fish species of commercial fishing interest. And when we think about in tropical areas, corals, but locally in colder water systems, the seabed, the benthic area, is a very important part of the ocean environment and can be substantially damaged by dragging lines and weighted nets and such over the seabed. As noted, the tragedy of the commons effect, where you have multiple countries without centralized control and multiple fishing interests, especially in international water, not being controlled, has created this tragedy of the commons. And this in turn is focused on the immediate near-term value of the fish, not in the long term. And indeed, it's been essentially publicly admitted by fishing interests that if they get theirs, then the other countries and other places won't be able to compete. So if the immediate value of the fish is perceived as higher than the long-term sustainable production of the fishery, that's what's driven the bulk of the increase in the fishing interests, even if it means that fewer fish might be available in the future. We, especially in the United States, but throughout the whole fishing industry, tend to be very focused on the short-term returns of the fishing venture. In total, over the last few decades especially, the overuse and harm to fish stocks has been significant without really thinking of the future consequences. When you look at this chart of fish catch in the Newfoundland Labrador Shelf, which is off the northeastern coast of Canada and the North Atlantic, most of the fish species that have been caught have been in decline over the time, especially since 1990. And cod especially was heavily overfished from its historic highs in the period from 1950 to 1990 to periods to where it became just a fraction of the overall fish production. And the consequence is that the traditional approaches to fishing over the last few decades are fairly well established as non-sustainable in the long term. There are simply too many different species being taken at levels that are leading to collapses of their population. So what is the current status of marine fisheries? In general, it's estimated that as many as 31% of the fish species are being caught at rates that exceed the replacement rate. About 68% is being caught at a more or less sustainable rate, but this number is changing with losses of fish, with the reduced production from the overfished species. More pressure is being placed on other species that currently are not in collapse or in serious decline. This concludes the third part of our lecture. You should move on now to the fourth part. In this final lecture segment on fish and food, we will be looking at the prospects of fisheries in the future. One of the key ideas that we mentioned earlier is the fact that there are more fish being caught than are being replaced through natural reproduction in the ocean. This notion of overfishing then is tied very closely, as one major alternative is to restrict harvesting of fish down to what's referred to as the maximum sustainable yield. This is very simply the amount of fish that can be harvested without decreasing the yield in future years. Think back to our earlier lectures where we talked about the natural interest. This is an excellent example of that, where if the natural capital is the total fish population of cod or herring or any of the major commercial fish species, the natural interest would then be the amount of fish that are produced by that population in any given year. So if we restrict fishing to that level, then we should not have declining stocks in the long term. It's estimated that currently about 68% of global marine fisheries are sustainably fished. If this is the case, then why do we have problems at the global scale? The problem is that the other 32% are overexploited, and that this number has increased significantly since the 1970s. And as we see more and more species becoming overfished, then we'll see increasing pressures on other species which have to date been sustainably harvested. So what is an overexploited fishery? It's one where the fishery are being harvested in numbers greater than is sustainable in the long run, and that this is likely to lead to a population decline and either a depleted or collapsed fishery. A depleted fishery is when a fish population is well below its historic levels but not necessarily collapsed. and that the population's reproductive capacity is low, meaning that the recovery will be very slow if it occurs at all. And this is in contrast then with the collapsed fishery, where the numbers have fallen to a very low level, less than 10% of the historic high. So what are some of the consequences when we deplete fisheries through overfishing? It's significant that the higher trophic levels, the predatory fish, such as cod, fishers, pursue the herring, crabs, and shrimp at the lower trophic levels. And this is fishing down the food chain. And from the standpoint where if the lower levels of the food chain are then later overexploited and collapse, then the whole ocean food web may collapse, and the total loss of fishing resources may ensue. And again, this is shown from the Canadian example, where the catches from the 50 to 90 were the higher level fish, and that following the 1990s collapse of those fisheries, or declines in those fisheries, then fishing pressures started to emphasize the lower trophic levels. And this again has implications for the total marine ecosystem if this continues. So what are some of the potential solutions to protect fisheries? There are several different practices that have been put into place. Some countries have established exclusive economic zones. The United States has done this. These are oceans zones where approximately 200 nautical miles from the coastline of any given nation is claimed by that nation to have exclusive rights over the marine resources, including the fish. They then have the ability to more effectively manage harvest by various fishing interests. There are also marine protected areas, and these are relatively large areas that are designated that are legally protected from various forms of human exploitation. These are especially important from the standpoint of being able to give depleted fisheries or stressed fisheries the ability and some time to recover. Marine reserves are areas where all fishing is prohibited and absolutely no form of human disturbance is allowed, including oil, natural gas, and other forms of, say, energy resource development. The goal is to establish sustainable fisheries. This is fishing at levels where the stocks are maintained at healthy levels and that the marine ecosystem is functioning properly. The fishing activity is reduced such that it does not threaten biological diversity. And things like bycatch are managed and minimized to reduce or eliminate inadvertent taking of species during commercial fishing operations. However, despite these efforts and despite these tools, which are increasingly becoming employed, there's many predictions by marine scientists that with the pressure on fish, and especially ocean fish, for future food resources, that our ability to solve the overfishing problems won't come through ocean practices at all. Instead, there'll be a greater emphasis on aquaculture. This is a practice of fish farming, and involves the rearing of aquatic species in tanks, ponds, or ocean net pens. The fish are treated much like terrestrial animals, cows, pigs, chickens, and such, where they're raised in captivity, fed, and harvested on an accelerated and optimized rate. They're protected from ocean predators and are allowed to grow without limitation of food availability. However, there are a number of issues with aquaculture and these sort of fish farming practices. It's become a very important aspect of seafood production globally, but the environmental challenges that come along with it are significant as well. So some of the problems with aquaculture: when you have fish species that are maintained in very close quarters, much like in animal holding areas on the land, You have greater prevalence of disease and parasites. This in turn leads to the use of antibiotics and pesticides. And because of the concentrated nature of these fish populations, they produce significant amounts of concentrated releases of waste into the marine or near coastal environment. They're being employed in places where mangrove swamps and other coastal wetlands are important and are displacing the natural habitat and natural species there. The fish meal that's used to feed these fish are from caught wild fish, so there's still pressure coming onto ocean wild stocks of fish. And one of the biggest problems is the highest level trophic level fish require large amounts of food. So it takes 4.5 pounds of fish meal, for example, to produce 1 pound of salmon, or 20 pounds of fish food, if you will, for it to produce 1 pound of tuna. And ultimately, there are growing concerns over the use of genetically modified fish species, and their escape or that their non-native fish will be released into areas outside their normal range. There are a number of solutions to these, and I would require that you read this section fairly carefully in the textbook. Aquaculture is likely to be required in the future to meet our protein demand from ocean species, and it has prospects for being able to provide significant food sources, but these problems will have to be addressed, and we'll have to have large scale efforts that are a better form of technology in the ocean to avoid some of these issues. This concludes our lecture on food, fisheries, and agriculture. To continue on now with the quiz for this unit.